Okay, so this is a question that we need to do node voltage analysis. Okay, so let's find the essential nodes and label them. So this is one essential node, let me call it V1. This is another essential node, V2. And this is also another essential node, but we have basically grounded it. So the assumption is that the voltage here is 0. This is our reference voltage. So now for node analysis, we need to write the KCL at these two essential nodes. Okay, so KCL at V1. Okay, so we need to look at the currents that are going out. So let's start with this one. Let's look at this current. Okay, so on this current, as you see, we see a voltage source here. Okay, so what I would do is that I consider the voltage here. So there's a 3 volt, the voltage goes up from this terminal to that terminal, right? So whatever the voltage is here, V1, so this voltage would be V1 plus 3 volt, right? So this goes up 3 volt. This is 3 volt higher than this, okay? So now that I call this V1 plus 3, now this current, which is the same as this current, and this is ground. So this is 0. So therefore the current here will be V1 plus 3 minus 0 divided by 1. So V1 plus 3 minus 0 divided by 1. Okay, so this is, I guess, the important point in this problem was to show you that when you have a voltage source here, so when this happens, then you can find basically use the amount of the value of the voltage, and then maybe you can find the current through other elements, through resistors. Here there was a resistor here, so I used the voltage here and then the potential difference to find that current. Okay, very good. So that is that current. Now the current going down is V1 minus 0 divided by 2. And this current is V1 minus V2 divided by 2. And finally, this current is, okay, now this current. Okay, that's also interesting. So for this current, we see there is a current source. So whenever you see a current source in a branch, the current of that branch is enforced by the current source. So therefore, in this branch, the current has to be negative to Ix. It's negative because of the direction. So therefore, here I will say negative to Ix equals 0. Yeah. So therefore, when you are writing the KCL at a node, again, if there's a branch and there's a current source, use that as a current of that branch. Okay, very good. So that was the KCL at node V1. Now, KCL at node V2. At node V2. So again, like this current is 2Ix. And this current, either you can say V2 minus V1 divided by 2, but also this is the value that we have, like they call it Ix. So the same, this is Ix basically. And then the current down is V2 minus 0 divided by 1/3 equal to 0. Okay. And then also always when you have a dependent source, we have to write the equation for that too. And Ix, as we see, this is Ix. So Ix is V2 minus V1 divided by 2 equal to Ix. Okay. This is for dependent. So we have basically 3 equations. We can solve it. Now, in this case, it's not that hard to solve this. So this is 3ix plus 3v2 equal to 0. So in other words, ix equal to negative v2. Okay. And then if I put here ix equal to negative v2, again v2 minus v1 divided by 2 equal to ix, which is negative v2. So v2 minus v1 equal to negative v2. So 3 v2 equal to v1. So I found the relation between v1 and v2 and this from this equation. And then now going back to the top equation. So we have v1 plus 3 plus v1 over 2, another v1 over 2, and then minus v2 over 2, minus v2 over 2. So instead of v2, I would put v1 over 3, right? Instead of v2, I would put v1 over 3 from this equation. And then minus 2ix. And ix is also minus v2 equal to 0. Okay, still I have v2. So let me get rid of v2. So this is basically 2v2. And then v2 is v1 over 3. Okay. So as you see, eventually we got one equation, which is we only have variable v1. Okay, so you could also just go with the top equation. You get rid of ix. Instead of ix, we put negative v2. Then you had one equation based on v1 and v2, and then second equation based on v1 and v2. You could also solve it that way. So v1 and v1, I have this 2v1. So that's 2v1. And then this one is minus v1 over 6. And then plus 2/3 of v1 equal to negative 3. So now so this is 16 minus 115 v1 over 6 equal to negative 3. So v1 is equal to minus 6 over 5 volts. Okay, so we got v1. Now I have v1, I can now easily find v2 from that equation. v2 is v1 over 3 minus 6 over 5 divided by 3 comes minus 6, 15. Minus 2.5 volts. Okay, good. So we got v1 and v2. And then also we need to find ix. So what was ix? Ix was negative v2. So ix was negative v2 amp. So 2.5, which is 0.4 amp. This is ix. So with this information, we have everything. We can calculate everything about the circuit. So it says find the voltage across all resistors. So let's do that. So I have V1 as, let's simplify this, negative 1.2. This one negative 0.4. So V1 is negative 1.2 volt, V2 negative 0.4 volt. Yeah. Okay, so let's look at, I'll do some of them, not all of them, but let's look at, for example, this 2O. This 2O, the potential, this side is V1 minus 1.2 volt, and the potential the other side is negative 0.4. So if somebody says, what is this voltage? Let's call it V of 2O. It's plus minus, right? So negative 1.2 minus that voltage, which is negative 0.4. Negative 0.8 volt. Okay, so you can do the same for others. For this one, this 1/3 ohm, it's the voltage is V2. For this one, I got it. And for this one, we know the current of that because we have Ix, and then we can find its voltage. And the same for this one. I have the voltage here, V1 plus 3, and then I have the voltage here 0. So this minus that divided by 1 gives me the current. The current. Also the voltage across that would be V1 plus 3 minus 0. So for the interest of time, I don't go through the details, but again, after when you have the essential node voltages, you can basically easily solve the circuit. And lastly, find the power of this voltage source. So for the power, it's VI, right? So we have this 3 volt voltage source. So its power is its voltage, which is 3 times the current. Remember, you have to always look at the passive sign convention. So you have to know this current. Okay, how do you know that current? For example, you can go from this current here. 0 minus this voltage, V1 plus 3 divided by 1, that gives you that current. Okay. So let me write this down. So the current here was 0, here minus V1 plus 3 divided by the amount of the resistor 1. And I already know V1, so that is watts. This is how much would be the power. Okay.